Let us first start in general with the idea of momentum p. Momentum is the product of the mass of an object and its velocity. It is a vector. This velocity can only change if there is a force acting upon this. If I write this down as dp dt, take the derivative, equals m times dv dt plus dm dt times v. And if the mass of the object is not changing, then the m dt is 0. Then what you see here equals ma. dv dt equals the acceleration. But we know that the ma is the force on the object. Let's call it the external force. You'll see later why I want to make that distinction. And so this tells you then immediately that dp dt, the change in momentum per unit time, equals the force, the external force on the object. And if there is no external force on the object, if this is 0, then dp dt is 0, and we call that the conservation of momentum. And of course, we use this not in general when we have one object, but when we have more than one, 2 or 3 or 4. If these objects interact with each other, then the internal forces between them, since action equals minus reaction, exactly cancel each other out. So if we have a collection of objects, and if the sum of the total external forces is 0, then the sum of the momentum of all these individual objects is conserved. And that is a very important rule when we're dealing with collisions. It always holds as long as there's no external force. Conservation of momentum always holds as long as there is no net external force on the system. So if we write this down in general form, P1 plus P2 equals P1 prime, that is after a collision, plus P2 prime. We're dealing here with two objects, and you can write this down as M1 V1, which is a vector, plus M2 V2, a vector, equals M1 V1 prime, which is a vector, plus M2 V2 prime, which is a vector. That is the conservation of momentum as long as there is no external force. And it always holds. It always holds, regardless of whether kinetic energy is conserved or is not conserved. If kinetic energy decreases, we call that an inelastic collision. Kinetic energy can even increase when there is an impact, by the way. Think about that. If kinetic energy does not change during the impact, we call it an elastic collision. But the conservation of momentum always holds as long as the net sum of all the external forces equals 0. Small example. Suppose you have a marble here and you have a piece of putty here. No external forces, so no friction, so we have to do this somewhere in outer space. I give the marble a speed, it hits the putty, it gets stuck to the putty. Kinetic energy is nowhere nearly conserved. Very inelastic collision. The two get together and clump together. But since there is no external force, only internal forces, action equals minus reaction, putty pushes on the marble, marble pushes on the putty, they cancel out. One is in this direction, one is in the other direction. Therefore, in this case, momentum is conserved. And that is very important that you are aware of that, and we will use that to our advantage many times.